Hello and welcome to SQL Server Analysis Services 112, Aggregation Basics in Analysis Services 2008. If you happen to watch the 2005 video, some of the slides at the beginning will be the same here, but I'm going to go through them much more quickly. So if the only one you're watching is 2008 and you have a question on anything I talk about in the slides at the beginning, then feel free to download the 2005 video. I go into a lot more detail on some of the topics than I will here. But I broke this into two separate videos because the tools in 2008 are somewhat different. You get to them in a different way, and there is an extra step in the wizard and just a couple of other changes like that. Basically, under the covers, the aggregation engine is working basically the same in both versions. Well, let's jump in. First of all, what are aggregations? This is one of the biggest reasons why you build cubes, because you have the ability to have these aggregations calculated ahead of time during the processing phase, so that when users run queries and ask for higher level values, they're already calculated, they can return immediately, rather than having to go to the cube and calculate them on the fly. So aggregations are just that, they're summarized values. Now typically you wouldn't store those in a relational database, although you could do it potentially in a star or snowflake schema. But having these built into the cube makes it much faster. You can imagine it sort of like indexes in a relational database, in the sense that when you run a query, the engine is supposed to figure out which indexes to use to make it most efficient for running that query. In a similar vein, when you run a query against a cube, the engine should figure out, are there any aggregations I can use to help return the data more quickly? So in order to create aggregations, you have to set this up inside of BI Dev Studio. And what's interesting is that when you go through the whole process of building your dimensions in your cube and setting the hierarchies up and creating attribute relationships between levels and so forth, you go through all this work, there aren't any aggregations being created by default. You actually have to go in, and in 2008 there is now an aggregations tab, which did not exist in 2005. Once you get into the aggregation tab, you choose the measure group you're interested in, and then there is a design aggregations button, or you can also right click, and I'll show you the various ways of launching this. But whatever you do, using the button on the toolbar or using the right click method, you'll launch the Aggregation Design wizard. And that walks developers through this whole process of building these aggregations. Now, aggregations are actually done at the partition level, and I haven't done a video yet on partitioning, but basically you can break your cube up into separate physical files. That does not affect how users see it and interact with it, but a lot of times people will break it up into separate partitions by time, for example. So they'll put each year in a separate partition, or they may put previous years in their own partitions, and then each month of the current year into a partition. And that way, it's useful for several things. One is you can process individual partitions at a time, and because aggregations at the partition level, you can aggregate current data much more heavily than prior data. And that can be good for processing performance, because if you do have to reprocess prior history, you're not spending as much time building aggregations there. And that's often done because prior data is not used as often as current data. Now, aggregation usage, this is a new step in the wizard in 2008. You could do the same basic thing in 2005, but it wasn't a step in the wizard by itself. And each attribute in every dimension that you have has four options: default, full, none, and unrestricted. Now, default is a default set of rules that looks at the type of aggregation, or I'm sorry, the type of dimension and the attribute, and determines whether or not it's going to consider that for an aggregation. It's actually very conservative in that most most attributes are actually not considered for aggregations. I won't go into the specific rules here, but for example, the granularity, the key value in each one is considered unrestricted. It evaluates on the fly whether it thinks it needs to or not. But special dimension types like many-to-many and data mining dimensions, and if you have a reference dimension that's not materialized, that is equivalent to none. And basically there are again a couple of rules in addition to that. I won't go into it, but default, like I said, is fairly conservative, so you can fine-tune this a little bit. One is you can say full and say that this particular dimension or attribute, has to be in every aggregation. Okay, that's not a good idea if this particular attribute has a lot of members, because the wizard has a cutoff, the 30% rule or the 1/3 rule, as I'll talk about in just a moment, and it may make such a large aggregation that the wizard won't build it. So if you set the wrong things to full, you may not get any aggregations. None, of course, simply says don't use this aggregation or don't use this attribute for any aggregations, and unrestricted says just figure out using your algorithms whether you should use this or not. So unrestricted and default are different, and again, default will eliminate a lot of attributes from consideration, whereas unrestricted, it will go ahead and consider that. Now, aggregation counts are interesting. If you know what the counts should be roughly, they don't have to be exact, but it's good to go ahead and set that value. And this helps the wizard figure out how many possible values there could be and whether or not it can even consider doing aggregations from that standpoint. Also, by setting these counts, it does help determine, if it does create aggregations, how to lay those out. Now, if you are working with a fairly small data set, you can just hit a button that will do the counts for you. But with a really large data set, that could take hours and hours, so you'll want to just type in what should be the actual values. And a lot of times during the development of a cube, you're working with a subset of the data. So let's say you're working with 1/10 of it, you can go ahead and let the thing count, and then you can just manually go in and adjust those counts to bump them all up by a factor of 10. Once you've walked through the wizard and you've set the aggregation usage and you've set the aggregation counts, it's now time to design it. And you actually have 4 methods here. One is up to a certain disk size, one's up to a certain percent, one is just until you click stop, and then one is don't create any at all. Now, the until you click stop seems kind of strange here, and you'll see when I run through this, of course, very small data set, so it works very quickly. But I have actually worked with customers before that have such large and complex cubes that they will kick off this until I click stop. They'll go to lunch, be gone for a long time, a couple hours, come back, and it will be at 1 or 2%. So this can be a very long process on large complex cubes or with really underpowered hardware. Now, the wizard doesn't have any knowledge ahead of time about what's a good query and what's not, and what's going to get used a lot and what's not. So it has to just make an assumption that all queries are equally likely. So since that's really not the case, a lot of people tend to use the usage-based optimization wizard. And what happens is that will log queries for you over a period of time. You turn the logging on and off. And then you run the usage-based optimization wizard. It reads the log and determines what aggregations should I build to answer these particular queries. And so once you get a pattern of actual usage and start building aggregations based on those, you'll get much better performance, hopefully, but you'll certainly get better aggregations designed to match actual usage. So a lot of times I recommend to people just start with 20%. That's fine for getting started. And then whatever your peak usage is, log that, and then run this usage-based optimization wizard. I'll have a whole video on the usage-based optimization wizard, or UBO for short, later. Now, I mentioned this earlier, the 1/3 rule. Sometimes people call it the 30% rule. I've seen both, and I know that 30% and 1/3 are not the same. But in short, the aggregation wizard is only going to create an aggregation if the size of that aggregation table is 1/3 or less than the size of the fact table. So in other words, it's not going to aggregate something that can be close to the same size as the fact table. And I just threw up a simple example here, and again, this is covered in more detail in the 2005 video, but I'll just show you briefly. If you had an aggregation with state, province, subcategory, and year, that would get created. You have 5,000 state provinces, 300 subcategories, and 4 years. That number is, I believe, 6 million here, and that's less than 1/3 of the 50 million fact records that you have. On the other hand, if you just make one minor change to that, you go from the year down to the month level, you've gone from 6 million potential to 12 million, or I'm sorry, you've multiplied by 12, so you've gone to 72 million. And of course, that's greater than the size of the fact table. This is just calculating the possible combinations here. But you can see that in that case, that aggregation would not be created. So let's take a look at what the aggregation wizard in 2008 actually looks like. So here I am in BI Dev Studio 2008, and I actually have opened the AdventureWorks sample database from Microsoft just because it's more complex and has more pieces to it. And if I choose to double click on the AdventureWorks cube, then you'll notice in 2008 there is a new tab for aggregations. So if I click this, it shows me, first of all, the measure groups, and I'll pick on one just for a moment, Internet Orders, that does not have any aggregations yet. Now, aggregations are stored in what is called an aggregation design. So one aggregation design contains one-to-many aggregations. So you'll notice that each measure group has either something already created, you can give it a name, by default it's just aggregation design, or it has nothing under it, for example here, unassigned aggregation design. You can then for each of these see how many aggregations are in that particular design. And of course some of these have already been created just because it's the sample project, but I'll walk you through the process as if none existed yet. So you choose your measure group that you're interested in, and I can right click here and say design aggregations. I can come down here and right click, same options, or there is a button up here on the toolbar that is design aggregations, the first one. They'll all get you to the same thing, which is the aggregation design wizard. So in the aggregation design wizard, I'll simply say next to step into this. I chose an already existing project because this one has multiple partitions. I haven't done that in the simple demo I've used in the other videos, but I just wanted to show what that is. This one happens to be partitioned by time, by year in this case, and each one of these has a source, and this query, if I expand this, I don't know that I can expand it far enough in this case, but they simply go out and filter by time. So what I'll do is I'm just going to select all of them and use the same level of aggregation for all the partitions. I could choose individual ones as well. And then I'll click Next. And this is the page of the wizard that you don't have in 2005. This is that aggregation usage, and I'll shrink this down a little bit. You'll notice that you have this default, full, none, and unrestricted. So I could come in here and say, for example, that in a promotion, the max quantity, I never need to, potentially I never need to use that in an aggregation, the same thing with a mem quantity. So I could set those to none. I could come down here though and say, fiscal year is really important, so I could set that to full. And I do get a little warning that says you shouldn't do this if it has a lot of members, but it's fiscal year, so it probably won't have more than 10 or 12 in most cases, and sometimes just 2 or 3. And so again, then if there's something that I might want in an aggregation and I might not, I can set that to unrestricted because again default is pretty limiting. Now I'm going to set all these back to default. I just want to show you that you can fine-tune these somewhat. And now I'll click on Next, and this is the count of these different items. And what I'll do is I'll go ahead and, you won't see these numbers change, but I'll go ahead and click Count, and it recounts these for me. It just ran a lot of queries against the relational database. But again, very small data set, so it's very quick. If I look at this, you'll see the attributes in the dimensions here, and then the counts, the number of unique values within each one of those. This partition count is actually just for the first partition. Just kind of strange how that works, but that is correct, so don't worry too much about that. So at this point I have my counts, and I will click Next, and this is that screen in the wizard where it's asking me, okay, what do you want? Do you want until a certain size of the aggregation on disk, a certain performance gain until I click Stop, or no aggregations? Now remember, the performance gain, even if I set this to 100%, it's not going to calculate every possible intersection. I mean, there are probably billions in this relatively simple cube, if not trillions, of possible intersections. Think about every possible combination of every attribute in here. It's just a mind-boggling number of intersections. So it's not going to calculate every one. If I put it at 100%, it's going to calculate every one up to that 1/3 rule that I talked about. Again, though, based on those other assumptions with the default, which a lot of the attributes won't even be considered for aggregations. So it's a fairly small number that will be created, even if at 100%. But I'm going to start at 20%. And this is a great wizard because in some cases with a lot of data or a very complex cube, this can take quite a long time. So you look really busy and you can do other things while this is running, and people think that you're working really hard. So I'll click Start, and it's going to initialize here and then run through and try to guess what aggregations are going to give me the best bang for the buck. In other words, it's going to try to start by creating the most useful aggregations first. And remember, if you think about it, again, we have the whole 1/3 issue, but if it can create an aggregation, let's say at the quarter level, it might do that and then say, well, now to get the year value, I only have to add 4 numbers up. So it can use that aggregation instead of having to go down to the base data. So those are the kinds of things it looks at first. Now notice in this case that I have gotten to 20% very quickly, and I have some values here that I'm going to record in Notepad. And so at 20%, it's created 21 aggregations. This is down at the bottom. 21 aggs, and it's a whopping 21.4 kilobytes. So obviously not much size here is being used at all. And let's blow this up quite a bit. That looks good. So now let me increase this from 20, let's go to 40%. And I'll just click Continue, and it will continue calculating from where it left off. So to double this from 20 to 40, watch what happens both to the number of aggregations and the storage size. Okay, so to go another 20%, I've gone from 21 to 55 aggs, so I've more than doubled that, of course. And my storage size is now up to 68.8. So roughly 3 times the size there. Now obviously I could keep going, and what I'll do is I'll just continue all the way to 100, and I'll pause the video here, and that way you won't have to sit there and be bored while it's calculating. And there I have it. It's going to stop at 99%, but that's fine. But you'll notice that to go basically the rest of the way, I'll just say, put in what it actually is here, 99%, but basically 2.5 times the last value, I've now gone up to 156 aggs and a storage size of 3 megabytes. And you can see from the graph that I got 70% of my value, or 70% of the performance gain very quickly, in less than 1/3 of a meg. And then I hit this wall where it's fairly low impact. I'm greatly increasing I triple my size and probably only have gotten 2 or 3% gain. Then I find some good aggs again, another flat period, and I go from here. But you'll notice that last 30% goes from less than 1/3 of a meg all the way up to 3 megs. So very much a diminishing marginal returns scenario for those of you with an economics or business background. But I'll go ahead and just go back to the 20%, and that's where I'm going to leave it in this particular wizard. Okay, and we're back to the 20% where I started, and at this point I'll click Next, and the wizard asks for a name for this aggregation design. And then you have two options. Go ahead and deploy and process these new aggregations now, or save the definition for these aggregations but don't actually process. You can imagine in large cubes the aggregation processing might take hours, which it can in fact, so you may not want to go ahead and kick off the processing immediately. You may just want to design them and let it happen overnight. At this point, I'll go ahead and finish the wizard. And notice now it returns me to an aggregation design. Notice I have a warning here. And if I hover over this, it says this is not used by any partitions. Well, that's because I assigned this aggregation to all four partitions when I ran the wizard. Well, I might come in here and say, okay, well, I want this aggregation design on this one. I want to use both of them on sales 2001. Well, notice I can't do that. So each partition can only have one aggregation design. You'll notice these happen to be the same here because I just ran through a 20% example getting ready for the video to make sure all of the pieces were working. So they do happen to be the same. But each partition can only have one aggregation design, but that aggregation design, of course, can have multiple aggregations. Now at this point, I would normally be done in 2005. In 2008, there is a built-in tool where I can actually examine, well, what aggregations were created. And in fact, I can fine-tune them and create new ones and drop them. I'm not going to get into that in a complete scenario now. There will be a video on that later. But that button is up here, and that is the advanced view. And I'll use the Aggregation Design 1 that we just created. And what I'll do is I'll select Aggregation Design 1 here. And I'm not going to do any sorting or ranges, but notice that this goes from A0, aggregation 0, to aggregation 21. There are 22 aggregations, and of course we have to start counting at 0, so 0 to 21. From there, I can expand each dimension, and I can see, well, a lot of these aggregations have promotion category. There are only 3 categories, but a lot of them use that particular attribute and none of the others. Okay, well, that's interesting enough. Sales territory looks like it's not used very much, but the group and the country and the region are all used in different aggregations. So let's leave that open for a moment, and let's drop down to product, which would be of interest a lot of times. Safety stock level got used. Probably don't need it. I could have probably set that not to be used. But obviously product category would get used a lot, and here it is in an aggregation here. And if I keep scrolling down, we'll see a couple of others getting used here. Days to manufacture, again, probably not terribly exciting. And here's product line, which probably would get used quite a lot along with the category. In addition, if I look at the date here, you'll notice that calendar semester got used once, fiscal semester got used once. Up here, fiscal year got used. Over here, calendar year, not surprising at the year levels. So again, later I'll talk more about this fine-tuning process. How do you know if your queries are using aggregations, and when you spot that one's not, well, how do you figure out what aggregation you need to create to do that? But that's it from the standpoint of creating these aggregations using the wizard. Again, later videos on usage-based optimization wizard and on custom aggregations. So remember that by default you go through that whole process of building your cube and the dimensions and all the pieces and parts there, but you don't have any aggregations until you come in and run through that wizard. I guess you could create them all from scratch, but typically you'll want to use the wizard at least to get started. Each of these aggregations, the aggregation designs, are a per partition design. So each partition in a measure group could have a completely different aggregation design behind it. And don't forget to set your counts. Let the wizard count for you if it's not too large a data set. Otherwise, just put in some good estimates. Again, they don't have to be exact. And finally, the recommendation I typically use that I mentioned before, set that wizard to 20%, let it go for a while in production. log queries, not constantly, but at times of peak or normal usage, and then use the usage-based optimization wizard to look at those logged queries and design the aggregations for you. So thanks a lot, and I'll look forward to seeing you in the next video.